So in this problem, it says an equilateral triangle is inscribed in a square, symmetric to a diagonal of the square. Let S denote the length of a side of the square. Then the area of the triangle is ks squared. We want to determine the exact value of k. So first we'll draw our square, and this has sides of S. And then inside of that, we'll draw an equilateral triangle. Now these are not the value of S, so we got to call it something different. So I'm just going to call it R. Okay. Now what we have to do is we can find the area of the triangle in terms of R, but we must somehow connect it to S. And so the way we do that is with the diagonal. Now the diagonal, it says the triangle is symmetric across the diagonal, which means it cuts this angle in half. What it also means is in an equilateral triangle, an angle bisector will be the altitude. So that's perpendicular right there. So this is 60, this is 60, this is 30, this is 30. So that means that this length and this length are both R, but individually they're 1/2 R, because this is a 30, 60, 90 triangle. So this length right here, in terms of R, is square root of 3 over 2R. All right, now, up here, this is a 90-degree angle. And so this right here is a 45-degree angle. We've already used up 30, so this is 15 and 15. These are also right angles, so this is 75 and 75. So this angle is 45, and this angle is 45. So that's important because this angle is a right angle all the way around, which means this right here is a 45, 45, 90 triangle, which means this length is also 1/2 R. So the length of the diagonal in terms of R is 1/2 R plus square root of 3 over 2R. Or if we simplify that, 1 plus square root of 3 over 2R. But we have to connect that in terms of S somehow. But if you look at it, this diagonal creates a 45, 45, 90 triangle. So the length of the diagonal in terms of S is square root of 2S. So these two quantities are equal. So 1 plus radical 3 over 2R equals square root of 2S. So what I'm going to do is I'm going to solve this for R. We're going to multiply by 2 first. So 1 plus radical 3R equals 2 radical 2S. And then we'll divide both sides by 1 plus radical 3. So 2 radical 2 over 1 plus radical 3S. All right. So that's our conversion factor. Now let's go back to the triangle. We need to figure out the area of the triangle. And so that's going to be 1/2 the base times the height. So if I turn it sideways, this is the altitude right here. And R is the base. So the area is 1/2 the base, which is R, times the height, square root of 3 over 2R. So that's going to be square root of 3 over 4R squared. Now what we're going to do is we're going to make this replacement. We're going to take out R and put radical 2 over 2 plus 1 radical 3 over 1 plus radical 3s. So square root of 3 over 4 times 2 radical 2 over 1 plus radical 3s squared. Okay, so I'm going to need to distribute the squared into all of this. So I have square root of 3 over 4. 2 squared is 4. Radical 2 squared is 2, so that's 8, all over 1 plus radical 3 squared s squared. Now off to the side, I need to expand this out, because I'm going to expand this like a binomial. So we have 1 plus radical 3 times 1 plus radical 3. So 1 times 1, 1 times radical 3, 1 times radical 3, and radical 3 times radical 3. So that means we've got 4 plus 2 radical 3. Okay. So down here I've got radical 3 over 4, 8 over 4 plus 2 radical 3. And I'll pull the s squared out because this whole expression is what we want. This is k. So at this point, all we have to do is simplify it algebraically. So I can take a 4 out of here and a 4 out of here, leaving 2. So we have 2 radical 3 over 4 plus 2 radical 3 s squared. And I can cancel a 2 here, here, and here. So I'm left with radical 3 over 2 plus radical 3 s squared. All right, so finally, what we have to do is to simplify this to get the radical out of the denominator, we have to multiply by the conjugate. So we multiply by 2 minus radical 3 on top and 2 minus radical 3 on the bottom. So 2 times radical 3 is 2 radical 3. Radical 3 minus radical 3 is 3. All over 2 times 2 is 4. Minus 2 radical 3 plus 2 radical 3 minus 3. So these cancel. And so 4 minus 3 is 1. So that means our value for k exactly is 2 radical 3 minus 3. There's our answer. And we're done.